Alright, welcome back. MECH2320. We're getting into chapter 25 now, and we're going to use Autotransformer starting. Another way that we're going to kind of control how much current or voltage, I guess, essentially gets to go to the motor in this case. So we're going to call it voltage per se in this scenario. So what really happens is when we're going to use Autotransformer starting, alright, we are going to control it so that the motor starts up on only 75% of its normal operating voltage, and then when it gets up to speed, then we start it over and connect it over into run. Okay, we use this with squirrel cage type motors, and when we connect them up, they're going to be connected in what we call an open delta. So in this case, so the past lecture we talked about reducing the inrush current. In this case, we're reducing the startup voltage, okay? Which also, if the voltage goes down, current goes down, they're directly related. But in this case, we're attacking the voltage, not the current, so we're going to make it so startup is only using 75% of the operating voltage. Once the motor's running, then we switch it to run and operates at 100% voltage. So this is how the open delta works, okay? With the connections, notice it's still iron core, all right? And it's an open delta. So what really goes on here, okay? So we have two sets of contactors here. We have a start and a run contactor. A start and a run contactor. So the startup contactor is for when we hit start. Notice start does not start the motor. Start energizes the relay coil. That relay coil starts impacting the timers, okay? So when we have this, we have two separate on delay timers. One's normally closed, one is normally open. The one at the bottom is an on delay timer, and it's normally open. You just can't see it there very well, so I'm sorry for cutting that off. But that's really what's going on here. So what happens there is we also have interlocking, right? Because we don't want it to be in the run and the start position at the same time. So that's why one's normally open, one's normally closed, and we have the interlocking. We have a mechanical interlock, all right, and we have an electrical interlock with the start and run normally closed contactors on the bottom two rungs as well. But notice when the control relay is closed, okay, that's when the timer kicks in. So since they're both on delays, all right, one timer is normally closed, one's normally open. So the one that's normally closed is going to open, okay, on after 5 seconds. Let's say 5 seconds just for the timer. I'm just throwing that out there. It's not specified on here. But what's going to happen then is, since it's on delay, what's going to happen is that timer is going to kick on, and we're starting in the start position, okay? So we can see that the timer relay that's tied to the start coil, so that's the second to last rung on the bottom of this diagram here. It's normally closed. So what's going to happen when that one's going to open, okay? Let's say after 5 seconds. So the control relay coil, or the relay coil, turns on, okay? Turns on the timer. The timer's going to count to 5 seconds. 1, 2, 3, 4, 5. Then what happens? That the timer on the second to last rung is going to open. So that gets us out of the start mode, and the timer on the bottom is actually going to close, right? The on delay. So after 5 seconds, that one will close, whereas the first one, after 5 seconds, it's going to open. So after 5 seconds, okay, one contactor opens, the other one closes, and the closed one goes to the run. So that's how we're doing it, all right? And we can use different taps there as well to help control the voltage and get it to 75%. So it looks a little funky, but that's our open delta connection. So there's how we use a run and start command for the motor using an Autotransformer to start it. Okay. Key to Autotransformer 2, very important. So with the reason we have, sorry, there was a breakup. I had to pause the video for a second because we had an announcement going on. So I don't exactly know where I was trying to thought, but I'm going to get kind of back into this here. Autotransformers, okay? What's the whole purpose of them? why do we want to do this? All right, yes, we're reducing the voltage, but the purpose of this is we have greater starting torque. All right, so in this scenario, we're going to have greater starting torque that takes place on this motor, and that's one of the other advantages as well. Okay, so just so hopefully you understand the schematic here and how we can use a start, all right, to reduce the voltage, and then how it actually switches over to a run command. So the control piece of that is very important here, how we switch back and forth between run and start, okay, using the timers there. All right, and this is a little hard to see. You're going to do something like this in class and be able to read the schematics. This is in your book as well. So, but I just kind of wanted to see how the control, how everything kind of comes together, where the relay contactor is at. So this is a much more complete wiring diagram. It is lacking, however, the numbers, so you know where to terminate it in the control panels and at the MCC and all those other things. So, but there's how our main wire up would go, you know, if we were to hand this to an electrician or something like that. All right, so let's talk about open and closed transitions starting. Okay, we use this for starters that have size 5 or smaller motor starter sizes. Okay, and it's for a brief period of time when the motor is disconnected from power, when the start contactor opens and the run contactor closes. Okay, so there's a small time period there, right, where what we talked about in the schematic before this one. All right, where we switch between run and start. Okay, there is a slight delay there, so we don't want to make sure there's a hiccup in power. So that's for open, and then closed transition starters we use on motor sizes that are 6 or larger. All right, and we have 2 separate start contactors used there. And remember, all this is for is to take care of that time delay between the start and the run switching, so that nothing drops out on the motor there. All right, so we got to make sure that we use a closed transition starter, and it uses 2 separate contactors there to do that. So, you know, not too intricate, but we got to make sure we're covering all of the bases for everything. All right, so if we take a look at you know, how that's going to look, all right, in our closed transition starter versus the one we had before. Okay, so we still have, you know, what's really different here is we have the starts with their contactors now. So we've added an extra contactor in. Okay, and we no longer have the interlock piece going on down below. So a little bit different in this scenario. You know, so like comparing it, we've added a few. We still have the control relay here that turns on the timer relay 1. Okay, so we now, instead of using, you know, 1 timer relay, we're using 2 timer relays. So before we only used 1 timer relay where we had 1 open and 1 close. But we have to set that extra timer relay in there that will account for when the transition piece actually happens. Okay, so that's really all we're doing in there. There's a small timer in there that actually makes sure that no power is interrupted in that scenario. Alright guys, well that's the end of this lecture. So as usual, email me, let me know if you need a Zoom or team call or anything along those lines. Else guys, have a great day. See you in class.